Lesson 2.4 is simply another example of converting a vector that's in the form of a magnitude and a direction angle into a vector that has its components according to an XY coordinate system. So here's what we have in this situation. Hydraulic cylinders are used to exert force in many mechanical devices. The force is exerted by pressurized liquid hydraulic fluid pushing against a piston within the cylinder. The hydraulic cylinder AB, so the hydraulic cylinder AB in figure 2.17 exerts 4,000 pounds of force F, I'm going to call it, on the bed of the dump truck at B. We want to express F here in terms of components using the coordinate system shown. So the coordinate system that we're going to be using is standard XY coordinate system. X is horizontal, Y is vertical. So we have this force vector, 4,000 pounds. It looks like it's acting to the left, but 30 degrees above the horizontal to the left. We want to express that in terms of its horizontal and vertical components according to our coordinate system shown. So to do that, what I'm going to do really quick is I'm going to draw this vector separately so that I can see it independently, and I'll label some specific things. I know that that's a 30, and I know that the magnitude is 4,000. Now what I'm going to do is I'm going to convert this into a right triangle, just as we did with the generic example that we saw last time. So I now have a right triangle here, and I know that this is my X direction and this is my Y direction. So really all we need to do is go through and, using right triangle trigonometry, determine the horizontal and vertical components of that 4,000. So to do that, I'm going to focus on this X piece first. This X piece right here. So I'm going to say that knowing that this is 30, I know that the sine, since I'm focusing on the X, I know that that side length is adjacent to the 30. So I'm going to do the cosine of 30 is adjacent, which is this X value that I'm trying to figure out, all over hypotenuse, which is 4,000. So to solve for X, that's going to equal X equals 4,000 times the cosine of 30. So 4,000 times the cosine of 30. And when we do that, we get 3,464.10. So we know that the magnitude of the force in the horizontal direction, as I just said, is 3,464.1 pounds along the horizontal. Now we also have that Y direction here. So to do that, I'm going to use the sine function. Sine of 30 is equal to opposite, that's the Y side, all over hypotenuse, which is 4,000. So this becomes Y equals 4,000 times the sine of 30. So 4,000 times the sine of 30. I believe the sine of 30 is a half, so this is going to end up being, 2,000. So this is 2,000 pounds. 2,000 pounds. So we now know both the horizontal, that's the X, and vertical, that's the Y, components of this vector F that is 4,000 pounds of force to the left, 30 degrees above the horizontal. But we got to be careful here because pluses and minuses matter. In the previous lesson, we learned that to express a vector in component form, we expressed it as vector F is equal to our horizontal component times this I thing plus our vertical component times J, or the unit vector J. So what is our horizontal component? Well, that's the x here, but we got to be careful because in reality, is this horizontal component acting to the right or to the left? Right is positive, left is negative. We see that the horizontal component is actually acting to the left. So it's actually going to be negative 3,464.1 I. And now we have the vertical. The vertical piece is acting up. Up is positive, down is negative. Since it's acting up, it will end up being positive. So it's going to be plus 2,000 J. So I've got negative 3,464.1 I plus 200 J, this being the horizontal and this being the vertical components of our vector F. Now we can check really quick just to make sure we got the right numbers by using the magnitude equation. We know that the magnitude of F is equal to the square root of each component, sum of each component squared. So negative 3,464.1 squared plus 2,000 squared. What do we get when we do that? So the square root, and in parentheses, make sure you always put that negative number in parentheses, 3,464.1. Otherwise, when you square it, it'll stay negative, which we don't want it to do, because a negative squared should be positive. Plus 2,000 squared, and we get just shy of 4,000, well, because of rounding we did. So we can see that, yes, those two do combine to give us the correct magnitude of 4,000 pounds. So again, breaking a vector up into its component forms is as simple as constructing a right triangle out of it and finding the vertical and horizontal pieces. The vertical piece has the unit vector j at the end of it. The horizontal piece has the unit vector I at the end of it. And this right here is our vector in component form.